Hello, everyone. Welcome to another episode of A View from Earth, the official podcast of Fiske Planetarium right here at the University of Colorado in Boulder. As always, my name is Tara. I'm a planetary scientist and a CU alum, also a presenter at the Planetarium, an outreach coordinator, and several other things. I know, Colin's counting on his fingers. I lost count a long time ago. Speaking of Colin, Colin's here too. Hi, co-host Colin.
Hey, I'm Colin. Yep, that's me. I'm an undergrad at CU. I study astrophysics and computer science. And I do this podcast and also present shows at the Fiske Planetarium. So that's me.
Sure enough. So today we are talking with Dr. Charles Danforth, who is a former professor at the University of Colorado, who has actually transitioned out of academia into the private workforce sector, which is what we're talking to him about. What is it like to spend all of this time in one career field, 20-something years, and then decide to do something different? And what that's like, and how it's totally okay to do something like that. And I particularly found this to be an interesting conversation because I am in the same boat, but in reverse. I spent a good 10 years in, not industry per se, but in a completely different field, doing like project management and IT stuff, and am now transitioning into a career in science and academia. So it was interesting to see how it's very similar, going the opposite direction.
Right. Well, and I, even as a 21-year-old, have my own version of that story. My whole life up before college, I was playing music, totally thought I was going to just do that for my whole life. And then I decided, I don't want to get burnt out and make this something that I end up really not liking to do. So I decided to study astrophysics and then learned, hey, computer science is really fun. What if I did that instead? And of course, those are much shorter timescales, but I think everyone has their own version of realizing what it is that they truly love. And of course, you have to find that through exploration and through what it is that you maybe didn't truly love.
Yeah, exactly. And even when I was in college, my first degree was in English and linguistics. What did I do with that? Absolutely nothing. Like I worked for a movie website for a while and wrote screenplays, but that lasted all of 2 years. And then I went on to do something completely different.
Right.
And even when I got to CU, I came in thinking I wanted to do theoretical astrophysics. And I got 3 weeks into my first physics course and said, no, I don't want to do this at all. But planets are awesome.
Yep.
So now I do planetary geology instead,
I think it can be hard though, because, a lot of these fields are so specialized, right? Okay, I'm going to graduate with the knowledge of physics, astronomy, and computer science, and then say down the road, communication sounds like something that I'd be really interested in, or maybe social work. I have no training in that at all. And part of Charles's whole message is, listen, your college degree, especially if it's in a quantitative STEM field, shows people that you can learn. It doesn't matter that you don't already know it, but you can learn it. That's what that shows, is that you are a teachable person and can kind of just take it and go. And
absolutely.
Really important.
And I think he made a good point too, that some of your skills may also be transferable too.
Absolutely.
He was very specialized in UV spectroscopy, which is not what he's doing at all. And he'll talk about this later, but it's more but he does have experience with telescopes and satellites.
Right.
Or even just data processing. That's a skill.
Or sundials.
Or sundials, exactly. You can take that. I use my project management skills all the time when I'm doing outreach work for Fiske, or even just managing my own time as a college student. Having a project management background was super helpful for that. It's some of these skills are definitely transferable, whether you think they are or not.
Yep. Well, I think, part of the trick is, and I don't know if there's anyone to blame for this or how that, kind of plays out, but we talked a little bit about career development and conversations about career development in college. And I think that there is a lack of encouraging students to market themselves as what they are, right? Which is someone who can learn, someone who is flexible, or what's the word? What brains do when they learn things. Anyways, you see the point that I'm making, right? That
Yes.
I know.
I get it.
So, and we're told, oh, well, you can put on your resume that you know physics or that you know these programming languages or whatever. I've never been told, I don't think, as a student, by a professor or an advisor, put that you are a learner or a teachable, student or whatever, like all these skills that are extremely valuable and that you definitely have. So, that's important, I think, to remind people.
Yeah, absolutely. And it's not something that we get a lot of assistance with in college. I mean, I went through 3 years at CU, and it's just sort of like, go to classes, do research if you can do research, because that's what grad schools want to see. And it's just sort of assumed that this is what you're going to do. You're going to take this step and this step and this step. And I like being able to talk to Charles and see that there are so many other steps. There are so many different directions that you can go. It doesn't have to be this very linear path that is laid out for you.
Correct. Yeah. Well, and we've had a couple of people on the show that have had very nonlinear paths. I remember someone else had a path similar to yours, Tara. Who did we talk to previously that really kind of jumped around? Was it this
I feel
season?
like that's happened with quite a few people, though, that we've talked to.
Yeah.
There aren't very many people who just went to college and got an astronomy degree and then went to grad school and then is doing the same thing that they were doing before. Everybody kind of, and even the people who do kind of follow that path end up jumping around a little bit between projects or different majors or stuff like that. So it's all, I mean, life should not be linear, I don't think.
Yeah. Well, and Charles he said, you get one life, right? I mean, excluding religious beliefs, we're here for the time that we're here. And then, so what are you going to do with it? You don't, you're not subject to the choice you made when you were 18, live your life.
Thank God for that.
Yeah. Right. Woo. Cool. Well, hey, what do you say we let Charles do some of the talking and jump into the interview?
Sounds good.
All right, so now we are talking with Dr. Charles Danforth, who is a researcher and development scientist at Maxar Technologies, which is a company that specializes in integrated space infrastructure and Earth intelligence. And for any locals, this is the sweet building in Westminster that looks like a satellite dish and is all made of glass. Very cool. After earning his PhD, he joined CU Boulder as a postdoctoral and later senior research associate, studying galactic interactions with their intergalactic material, odd types of quasars, and the cosmic web. He's the principal author of COAD X1D, the industry standard algorithm used to reduce and combine Hubble Space Telescope and cosmic origin spectrograph spectra, and has worked with a number of space telescope teams, including Hubble Space Telescope, the Chandra X-ray Observatory, and the Cosmic Origin Spectrograph. He is the dad of 2 precocious kids, a runner of mountain hills, a brewer of beer, an explorer, and a seeker of adventure. Dr. Charles Danforth, thanks so much for talking with us this morning.
You're welcome. Glad to be here. I see you found my webpage.
Yes. We'll talk about it. It's a great webpage.
Thanks.
So we'll go back a ways and start kind of, I say from the beginning, there's obviously more before this, but where did you go to school and what did you study there? And how did that lead you to your tenure at CU Boulder?
Sure. So I went to Swarthmore College, which is a small liberal arts college outside of Philadelphia, top flight place. It's an interesting place. It wasn't, research and science and stuff wasn't the main focus. It was more of a holistic liberal arts thing where you have to learn all kinds of stuff. I had to take classes in Russian and in philosophy and, Asian art, things like that, which, I didn't necessarily love at the time, but, it's been a good thing later on in life to have a more broad background. And I studied astrophysics there, which was kind of a make your own major. They had a physics major and they had a bunch of astronomy classes. So I sort of rolled my own major into there, which was physics requirements plus all the astronomy classes I wanted to take, and we called it astrophysics. It was a small place. We only had 10 physics majors in the whole class that I graduated with, but it was fairly terrifying for me. I came from a small town in northern New England where, yeah, I was the smart kid in class, and there was never really much doubt about that. I got to college, and suddenly I'm with people who are way smarter than me, and speak 3 languages, and play 2 instruments, and are super, super nice. So you can't even really hate them. So that was, that was kind of tough for me, and really made me step up my game.
And this was your undergraduate education?
This was undergrad, yeah.
Okay, and then you graduate with a degree in astrophysics. Is that what does your undergraduate degree say on it?
It says, gosh, I have no idea. It says it says BA in astrophysics.
Nice, nice. Okay, cool. So now you have your BA in astrophysics. Then what?
So then I was like, well, okay, I'm, the next thing to do. I've always wanted to be a professor, right? This is where it's all at. So I applied to a bunch of grad schools, including CU. Didn't get into any of them. So I said, okay, now what? And I, cast around for a bit, and I found a 1-year research position at University of Kentucky. Now, I always kind of regretted that I never took a semester abroad in college. So going to Kentucky was kind of a semester abroad. I mean, it was great. I had a wonderful time there. I didn't know anyone. It made me sort of, it made me grow up. It made me learn to cook. Learn to be an actual adult. Just chill out after undergrad. Took the GREs again. Applied to even more schools, including CU again. Got rejected again. But in the meantime, I'd gotten into some other schools. So I ended up going to Johns Hopkins in Baltimore. So I guess the formative thing here is, this was my first time somebody said no. This is my first rejection, which, for this smart kid from rural America, that was a big deal. So, again, I got to Johns Hopkins, Baltimore. Baltimore is a great city to live in for a little while. A really fun place, great department, lots of fellow astro and physics nerds there. We had a wonderful time. Met the woman who would become my wife. Got a lot of hobbies and things like that. More importantly, I guess I got sucked in onto the coattails of various big projects like the Hubble Space Telescope, like various other satellite hardware that we got involved in, and would then sort of go on to become the basis of all my research.
So then you graduate from Johns Hopkins. You've earned your PhD in astrophysics.
Yep.
And you seek a job in teaching, a professorship, or.
Well, so that's the thing. Like I never really thought through like what do you need to do to be a professor? And I was super into the research. The gravy train of funding was great. Hubble Space Telescope was good things going on there. I had great connections with more senior researchers in the field, so I could do a lot of things. I wanted to do research. I got a postdoctoral research offer from CU. And for those who aren't familiar, postdoc is sort of typically about a 1 to 3 year temporary position. It used to be, you do a postdoc while you look for your faculty job. Well, nowadays maybe you do 2 or 3 postdocs while you look for your faculty job. But it's a limited time thing. So I got to Boulder and I was like, oh, this is great. Not only is the research great and the place is great, but there's all these awesome things to do. There's all this rock climbing to be done, and hiking and skiing and camping, and you name it. And it's there to be done. So I was in no hurry to leave. The Hubble. So I was hired on to be. So my specialty has always been in spectroscopy, which is kind of it doesn't get a lot of press because it's boring, but it's where a lot of the science comes from. So my specialty was ultraviolet spectroscopy from space. So I got hired on to work with the Cosmic Origin Spectrograph, which was being built at CU and operated from, Jim Green at CU was the PI for the instrument. And, they installed it in Hubble, and then, it was awesome. It was great data coming down, and all kinds of awesome research to be done, and a good group of people all doing similar things. next thing I know, 10 years have passed. So my 1 to 3 year research position in Boulder is suddenly, that was 10 years ago. Huh.
I have to ask, just from a personal standpoint, as someone who has also been rejected from many grad schools, when you came back to CU for your postdoc, was there some sort of like a feeling of vindication at that point?
Yeah, there was sort of a, here I am anyway. But honestly, I'm not the same person I was back then when I got rejected. And, I'd like to think I'm a little bit better. Also, if I had gotten into CU as a grad student, I would have spent, 4 to 6 to 8, whatever, however many years at CU. And then I would have had to leave. No, I wouldn't have to leave, but, a lot of people will, you'll have to go somewhere else. And after having lived here in Colorado, there's not a lot of places that I want to live. Maybe a longer list of places I'd be willing to live. Yeah, it all came
Totally
down
fair.
to priorities.
For sure. So you came to CU, you did your postdoc, and then you ended up here for, like you said, quite a while. But then eventually your life took a pretty major turn out of academia.
Well, a couple turns. I mean, I had, the research funding started to dry up, and frankly, my interest in doing the research, doing the same stuff I've been doing for the last 10 years, I just wasn't that excited about it anymore. So I started, at one point, one of the faculty came to me and said, "Hey, do you want to try teaching a class?" I said, "Sure. That's something professors do, right? I should try that. How hard can it be?" Turns out it's pretty hard. I taught a class, and it was an introduction to cosmology class for non-majors. It was super fun. It was an incredible amount of work. It was very rewarding. I had no idea that the shy dorky kid from high school, I would actually like stand up in front of 100 undergrads and talk for an hour at a time, and it was awesome. It was amazing. That was a huge revelation to me. So then I switched over to primarily doing teaching. I taught for, 7 years, I guess, off and on. It was always the introductory classes, the Astro 101 type stuff. And I did that because largely the real faculty, they don't like teaching those classes. And I don't know why. Maybe it's too dumbed down or something, but it's really not. I loved teaching the intro classes because you get a bunch of students. Well, because I mean, astronomy is the cool science, right? It's, you have some humanities major who, go, well, I have to take some science credits. Well, okay, astronomy, that sounds fun. So people are in there because they think it's going to be fun. So I figured my job is sort of to make it fun. Let's inspire. An inspired student is going to learn better. You can be the best teacher in the world, and if the student doesn't want to learn, they're not going to learn. So that was always a lot of fun. And the non-majors, they're not afraid to ask the dumb questions, So I would get all kinds of wacky questions, and sometimes, they were, I don't want to say dumb. There's no dumb questions, but sometimes they were pretty weird. But every now and then you'd get just a really insightful question that, like, those of us who are majors, those of us who are trained in this stuff, we would never even think to ask.
Do you remember any specific questions that a student asked that really made you like stop and appreciate the fact that they were asking the question?
Yeah, so one point, one student asked me, she said, "Why is it that stars have points?" And I said, "What do you mean?" She said, "Every time you show us a picture of the sky, you show us a picture of from the Hubble telescope or whatever, the stars all have this like cross on them." And I was like, "Oh, I never even thought to ask that question." But this is okay, great. So now let's talk about telescopes. Let's talk about diffraction spikes from the secondary mirrors, things like that. And I never thought to even think about that question.
That's very cool.
Yeah.
So then you were teaching for a while, and then academia just wasn't doing it for you anymore.
Well, so the teaching was great. As I went on, I started out, the first time I taught a class, it would take, I don't know if people realize this, it takes like 10 hours of preparation per hour of lecture to come up with just a really good lecture, and plus the grading and the tests and all that other stuff. And then the second time you teach the class, it's like 5 hours per hour. And after you've taught it for a while, it never gets down to zero, but it gets a lot easier. Eventually, after I've been teaching the same class for 5 times, it's okay, what are we talking about today? Oh, black holes. Okay, pull that one out, put it on. There we go. So it's getting a lot easier, but in some ways it was a lot less challenging. It was less fun. It was still fun. I loved interacting with the students. I loved interacting with most of the students. But it just wasn't quite as much fun anymore. What finally I think was the straw that broke the camel's back was just, I don't do this for the money. I didn't do this for the money, but at some point the money becomes necessary. And as a non-tenure track professor, instructor, the university teaching load to be considered a full-time professor is huge. And it doesn't depend on size of class, number of students, or anything like that. It's just a number of classes you teach in a semester. And there's just no way that I could teach 4 classes in a semester. That's nuts. So eventually, and I was getting bored with the research, and it just, it's time for something new. I realized I've been doing the same thing in life I've been doing a career that I decided on when I was 18 years old. And now I'm, not, I'm, 40 something. Maybe it's time to consider something different. What else can I do?
And it sounds like, reading through your blog, which if you're listening, you should check out because it's great. It's called the Outer Sanctum. That someone at some point told you something. It sounds like just said it's okay to change your mind. What happened there?
I'm not sure that was something anybody ever told me, but suddenly I realized I'm not the same person I was when I was, in high school or college. God help us all. I don't have to, this idea of, you go to college, you get married, you have a career, like that's very old fashioned. Even in my parents' generation, that wasn't necessarily the case. People these days can have all kinds of careers. You only get to go through life once. So what am I waiting for? Let's try something different. It's okay to change your mind on what you want to do.
And that is when you decide did you apply for the job that you have now, or did someone reach out to you? How did you get connected with the company that you now work for?
So that was the big thing. It's like, okay, well, what else can I do? What am I good at? I'm really good at, I can teach and I can do ultraviolet spectroscopy. Those are like the 2 things that I'm really, really good at. But then I realized, like, I can do more than that. I can learn. You can teach me stuff. I'm a smart guy, right? So who do I know out there in the field? Well, there was, I knew various spouses of coworkers or social friends of mine. Oh, hey, you work at company X. What do you guys do out there? Do you need anybody who can reduce ultraviolet spectra? Ultraviolet what? So that was a bit of a shock. Like, oh, we can't just translate these things 1-to-1. Well, I'm pretty good with computers. Oh, okay. Well, now, maybe that's something we can do. Do you know this particular software package? No. Do you know this? Never heard of it. So there was a lot of back and forth there. I went through all the usual job sites, Indeed and things like that, just looking for positions. Applied to a bunch. Basically nothing. What changed things around was networking. I hate it that this is sort of how it is, but the way you find a job is by a friend of a friend of a friend kind of thing. And I ended up, the wife of a close colleague of mine worked at what was then Digital Globe. She knew a guy who used to be an astronomer. I talked to him for a while. He knew another guy who was the head of the R&D department. etc. Eventually, I said, hey, well, why don't you come on in for an interview? And there we go. And I got lucky. And this took a while. This took, I think between the when I finally mentally said, okay, it's time to go, it's time to do something different, to when I actually got the job offer, was probably a year and a half, almost maybe 2 years. I mean, certainly it was a solid year of work, solid year of actual looking.
But then you accept the offer to work for Maxar Technologies, or formerly Digital Globe.
It was Digital Globe at the time, and then as soon as I got there, it changed to Maxar. So
got it.
Confusing.
Yeah, it looks like Maxar absorbed Digital Globe as a kind of a subsidiary. Is that correct?
Yeah, it's very confusing for me as somebody who just started there. As originally it was Digital Globe, which was the satellites looking down at the Earth, and then a couple of other companies which did, so you said early on, the space infrastructure and Earth intelligence.
Right.
So the Earth intelligence side is the imagery and the looking down stuff. The space infrastructure is sort of the other half of our company, which builds the satellites. So and I came into the company thinking, oh, I know all this stuff. I didn't know anything. Oh, I'm pretty good with computers. No, you're not. I came in talking about, I'd done this survey with Hubble, and I had accumulated 100 quasar spectra and reduced it down to 10,000 different. I put this catalog out, and I said, so I came in and I was talking about big data, big data. And they said, well, how big is your database? And I said, oh, it's probably about 1 gigabyte. Each one of the images that we pull down from the satellites is about 50 gigabytes.
That's a lot of images.
And we pull down, several thousand a day. It's staggering, just the sheer quantity of data. And I said, I said, well, I'm a pretty good computer programmer. No, I have gotten a lot better over time. Certainly one of the little tasks that I'd done sort of in preparation for moving out of academia was I really need to get my Python better. I need to move to a real language. I need to, become better at Python. So it was like eating my vegetables. You have to go and, well, I could do, whatever problem this is, I could solve this in 10 minutes using, whatever language I'm used to, or I could sit there and do it in 3 hours in Python. But then eventually it got easier and easier and easier and easier. And now it's, I don't speak IDL anymore. It's, everything's in Python now. But still, I work now with, actual computer scientists or software engineers or something like that. And, I don't understand their code. It's beautiful, but I don't, I don't understand how it works.
Well, so we're talking a lot about the the specific kind of things that you would do, but kind of in a nutshell, what was your role with the company? I mean, obviously you're an expert in reducing spectra, you're doing some kind of computer sciencey stuff, but what were you hired at Maxar to do?
So I was hired in the R&D department, research and development. I liken my role to sort of they might not agree with this, but I think of myself as kind of the crazy guy they keep up in the attic to come up with weird ideas, which is not true. I get put on all kinds of different projects. So R&D is the group that is sort of the speculative, hey, can we come up with a way to do X? And then, the product people say, well, hey, we can actually use that. That's one of the things about industry is that, no longer are we looking to publish a paper. We're looking to, bottom end of the day, we want to make money, right? So what can we do that makes money? So we have more free reign than a lot of people in the company to just work on speculative, weird things. I've done all kinds of projects. There's a lot of money to be had in object detection. Can you train a artificial intelligence, which is a phrase I am deeply skeptical of the more I learn about it, to recognize, ships or cars, or, can it tell the difference between forest and cropland, what kind of cropland, things like that. There's a lot of money in that. Can we differentiate different types of minerals? This soil is high in carbonates and this soil is high in, something else. So we do a lot of work with that. Maxar has 4 satellites. One of the satellites has, it's called multispectral. It has visible and infrared channels. So sort of in astronomy parlance, it has 16 different filters that it can look in. So you can kind of construct a very crude spectrum that way. It's not really a spectrum like spectroscopists would call it, but it's kind of narrow band imaging. With those, we can tell the difference between different types of materials, for instance. There was a company that wanted to know what materials the roofs of their buildings were made out of, or the roofs of buildings were made out of. Well, we already have a product that has it has the footprints of all the buildings in certain areas. You can go on the map and you can see here's a little rectangle and so forth. So we can pair up, that roof, that building, the top of it is made out of metal or polymer or whatever. Can we detect, say, solar panels? So there's all kinds of really cool, interesting projects. One of the things I'm doing now is we're utilizing the infrared imagery. This is called shortwave infrared SWIR, which is sort of 1 to about 2.5 microns wavelength. SWIR can see through smoke. Smoke is more or less transparent, so we can see forest fires. So it's really cool. And unfortunately, the last couple of years have been big business for firefighting, for wildfires. So we can see through the opaque smoke. We can see in the infrared. We can see, here's the fire there. So that's one of the things I've been working on a lot lately is trying to map, what can we do with the SWIR regarding wildfires.
And I'll just reiterate really quickly that you're looking at the tops of buildings and picking out solar panels with satellites in space.
In space, exactly.
Like, this is not an airplane that's at 30,000 feet. This is outside of our atmosphere. That's insane to me.
Every now and then that blows my mind. Like, oh my God, I'm sitting here, I want to go for a run later on today, and I want to say, oh, is there a trail over there? I'm looking at images from space, from 600 kilometers up. We're seeing, is there a trail up Green Mountain?
That's craziness.
It's pretty awesome. What sorts of processing goes into these images before they're released to, say, viewers on Google Maps or, wherever?
So we do, we have to orthorectify it. So first an image is taken from, maybe at an angle, or there's terrain or something in there. We have to shift and distort the image so that it looks like you're looking straight down. And to do that, you need, not just where is the satellite looking from, but you need to have a model of the terrain, so you can unwarp that. That's why sometimes if you look at like Long's Peak, it's very tall, it's got very steep things. Like around the edges of it, it gets all warped and weird looking. That's because it's being warped, so it looks like try to look if you're straight down. We do an atmospheric correction, so we remove the effects of haze and the effects of water vapor sometimes, to try to get as good as you can. Certain areas are notoriously hard to get good imagery of because they're cloudy a lot. Scotland, Canada, things like that, they're often very cloudy. So we don't tend to have as good imagery of them. Places like China, sometimes in Africa, sometimes it's just so hazy that it's just really hard to get a good image. And sometimes when you see degraded imagery, sometimes it's because we haven't imaged it in a while. Sometimes it's because it's just really hard to get a really good picture of that city.
So is this all done with specifically Maxar satellites, or are you also pulling in data from like Landsat and things like that?
This is just us. We will consult Landsat and other satellite data, but no, we have our fleet of our 4 satellites, and soon to be later this year, we're launching another 6. Worldview Legion, hooray! Which is going to just revolutionize things. So this is all our satellites. And they're run from, our facility up in Longmont, where they have the people it looks like mission control, and they're in there with all the computer banks, and they're, monitoring the satellites, and, oh, let's get a picture of that. Let's get a picture of that. It's wild.
So this, there's a lot of space science and kind of what feels like astrophysical work built into this. And so I'm curious, how has your background as an astrophysicist influenced the work that you're doing at Maxar?
So that's a great question. Astrophysics wise, well, I mean, knowledge of physics is good in spectra. It's sort of what is happening with the light as it travels from the sun through the atmosphere to the surface of the earth and back. That helps. Knowledge of astronomy has been very helpful. Knowledge of, my experience with Hubble has been actually really, really useful. It turns out that, a telescope in space looking up and a telescope in space looking down, there are a fair number of similarities to it. So just my experience with, planning observations, knowledge of orbits, things like that has been very helpful. I can give you one sort of fun example. We were doing a project at one point where we were trying to identify telephone poles in satellite imagery. We're trying to train the computer to find telephone poles, power poles, things like that. Well, if you think about it, if you're looking from straight above a pole, what do you see? Well, you don't see anything. You see the shadow on the ground, right? Because that's all you see. So I said, okay, well, this is pretty easy. The satellites fly overhead every day at 10:30 in the morning, more or less. So the shadows are always going to be pointing to the northwest. And my coworker said, well, why? I said, because it's a sundial. Like, this is the oldest astronomy technology there is, a sundial. And so now they think I'm some sort of wizard because, I understand sundials. So, what you can do is you can now set the computer up to look for lines pointed to the northwest, and that's probably a pole or some tall, skinny object, smokestack or a tree of some sort. So that's an example of where it's coming to. We had another project. We were trying to determine the materials that buildings are made out of. And I said, because of where the sun is and where the satellite is, we're going to be able to see the south and east faces of the building because it's going to be illuminated by the sun. Except in the southern hemisphere, because it's going to be the north and east. But just because of where the satellites orbit and where the sun is at that time of day and so forth. So that's a case where a little bit of astronomy knowledge has come in helpful.
Super cool.
Yeah.
And of course, probably one of the, some of the people that are very interested in all of this satellite data, looking down on things from above, is the military. There's a lot of military applications to this. Can you tell us a little bit about the sort of relationship between like the science that you're effectively doing and how the military is using it?
So first off, I don't know. I am not cool enough or whatever to have what we call clearance, classified access. And honestly, probably if I were, I couldn't talk to you. I can guess, obviously there's a lot of interest from, government agencies, be they whatever they are. And I don't even know which ones they are. In our data, the government has their own, the military has their own set of spy satellites, but ours are up there and they work. So a good portion of our, as far as I know, a good portion of our funding comes from government contracts, and certainly they're taken very, very seriously. Things that they're interested in are, and not just the military, but a lot of people are interested in change detection. We don't necessarily care about the image. We just want to know, has anything changed in that area, wherever that area may be? Are there more ships than usual there? Are there, have been people built new roads, things like that? There's the obvious things about, we can take an image and we can see, tanks or whatever moving around. So there's a lot of interest there. In fact, when the satellites are designed, a lot of their capabilities are driven by, government applications. For instance, I said the 31 centimeter resolution. Well, why did we pick that? Well, that's the scale that you can see, details of, people moving around. There are other satellite companies out there that get a lot of good press about, we can image this and this and this. Their resolution isn't that great, so they can see, they can see a ship maybe, but they can't necessarily see the people on the ship. There was a month ago or so, there was the Ever Given, the cruise, the cargo ship that was stuck in the Suez Canal, which was hilarious. And I was watching on social media, satellite company X post, here's our picture of the ship, and company Y, here's our picture of the ship. And it's like, I know we've taken a picture of the ship. I know we have, and we're just waiting. And all of a sudden, the Maxar picture comes out, and you can read the text on the side of the containers. Like, that's how it's done, guys. So, so a lot of our capabilities are driven by, government applications. Things like, and even in not just our technology, but in astronomy, like the Hubble Space Telescope it's a 2.4 meter mirror. Like, this is not a coincidence. It turns out that the people who made the mirror and made the satellite have experience in making 2.4 meter mirrors. I mean, this is all conjecture, we don't know, but we assume that some of the big spy satellites from 20 years ago, 30 years ago, look a lot like Hubble. They're just pointed down rather than up. So this is a nice benefit for astronomy.
So getting back a little bit to your kind of career in STEM and now moving into industry, you're obviously advocating for that people with STEM degrees have way more options than just academia. Why is this sort of like an important thing to you? And what are some of these alternative pathways? They don't really present us those when we're in school.
Exactly. Yes. Okay. So first, why is this important to me? I feel, I wouldn't say that I wasted 20 years of my life. Not hardly. I'm very proud of what I did. I'm certainly teaching people, and the research that I did, I'm very proud of that. But there's a lot of heartache and a lot of people, I think, suffering that goes on that doesn't need to go on, for people feeling like they're on the straight and narrow in the academia because they never see, like you say, they never see these other options that are out there. I used to do a lot of undergrad advising. People would come to me and say, well, I think I want to go to grad school. And I said, why? No, really, why? I mean, you need to have a really damn good reason to put yourself through it. Your grad school is not just more college. I enjoyed my time in grad school, but it didn't put me ahead in life in terms of retirement savings or any of that stuff. So I do wish that there were more career development. Here's what you can do with a degree, be it undergrad or graduate degree in a science. To some degree, I think it doesn't really matter what you major in. I heard a statistic, I don't know if this is true or not, but it feels right to me that 15% of people do for a career what they majored in college. Like, that's it. I'm one, but a lot of people aren't. So what you major in kind of doesn't even really matter. I mean, maybe, some sort of science or STEM field is better if you are going to become a STEM person. I look at who my coworkers now. We have a lot of them are PhDs in R&D, but we have computer scientists, mathematicians, forestry, geology, all kinds of things. So the thing I think is more important almost than what you major in, and some base knowledge is good, of course. It's the ability to learn, the ability to teach yourself. Somebody said to me at one point, a PhD means you don't need to have someone teach you anything anymore. You don't need to have classes anymore. You can, if you need to learn something, you can just go out and learn it, which I think I didn't understand at the time, but I think I do now. So we get the problem. One of the problems in academia is that you're surrounded by professors who have started out doing this and have always been doing this. So you kind of don't know any other lifestyle. one of the reasons I'm excited to be on the Fiske podcast is because, here I'm a guy who left and came back, and here's sort of what I found in the jungles out there. I actually have a follow-up to the blog article about changing your mind that I wrote the other day about sort of what did I find. And it's not nearly as interesting, but there it is. I mean, there are a few things I do miss about academia. I miss a lot of the people. I miss a lot of my friends back at APS. I miss the teaching for sure. I miss sort of the open intellectual environment. When I was doing research, I would go to a conference and say, oh, hey, I'm doing this cool project and we're doing this and this and this and this and this, and everybody was, oh, this is great. I do just as cool stuff now, but I can't just blather on about it. And it's not just from a government security standpoint, but it's a intellectual property. Like, oh, I don't want to go talk about this awesome method we have for finding swimming pools because somebody from another company or somebody said, oh, hey, that's a good idea. I can steal that and run with it. I
never thought about it from that kind of perspective.
Yeah.
But yeah, I know, like,
he loves to talk about what he does.
Yeah, that's all scientists want to do is talk about their science.
Right.
That's very
They're allowed to. It's all they're encouraged to, right? I mean, that's
right.
Collectively how it works is you talk about it and show other people and they build off of it. But now, if you're working for a company and your livelihood is based on you being the only person that has, the technique that you developed, then it kind of changes things.
Yeah.
So I think it can be easy for folks to feel like, after they've spent a significant amount of their life in one area, like we've been talking about, academia, for example, but really anything, that they can't change their mind, right? Oh my gosh, this is what I know how to do. I've never learned how to do this other thing. I'm not educated in this thing or whatever, so that it can be difficult to change the direction of their life or their career path. Is this something that you experienced, Charles? Or whether or not it is, do you have any thoughts about, getting over that kind of fear of change and, kind of embracing?
It's absolutely hard. I'm not going to pretend that it wasn't hard or even that it was fun. I all this writing resumes and applying for jobs and all that. I mean, it was awful. It was not fun really at all. And, even the networking stuff, I'm a pretty outgoing guy, but even that was pretty far outside my comfort zone. But, I think it's, no pain, no gain. No, that's not true. You've got to take risks, in order to have rewards. I think a lot of people in career choices and everything else get sucked into this complacency. Well, I've already spent 10 years doing X, I guess I don't want to start over. You're not. You're still taking the lessons you learned from your past, whatever they may be, and applying them to something new. Think back, how many people haven't made some dumb decision back in their early times and been able to move beyond it. And I won't say that my past was a dumb decision. I mean, that was, I'm proud of what I did and I stand by it, but it's time for a different movie.
I've always thought it was very strange that people expect us to make a decision at 17 or 18 years old, what we're going to do for the rest of our lives. Right. That doesn't make any sense to me.
Yeah. When I was doing undergrad advising, people would come in and say, well, I want to be my career, I want to be a speech pathologist. Like, okay, that's great. That's a wonderful career, but that's very specific. You're 18 years old. I mean, maybe you'll change your mind sometime.
Well, and speaking of advising, do you get a chance to do much work with younger people now that you're sort of in industry? Is that something that's still an option for you to mentor or anything like that?
Really? I mean, I've given talks to my kids' classes about stuff, but no, I regret I don't get a chance to teach. I don't get a chance to interact and, pay it forward and so forth. And maybe that's because I won't say the young guy on the team, but I'm the new guy on the team. We do occasional research seminars where we talk about, here's my project and here's what we're doing, and sort of brown bag, throw ideas around. But no, I don't get to teach. I don't get to mentor, advise, things like that. Given the pandemic, I'm just as glad that I out of academia when I did. I see my friends who are teaching classes over Zoom and things like that, which, my classes would have done okay over remotely. It would have sucked all the fun out of it for everyone. So that's off to the faculty out there that have been teaching for a year plus now in this bizarre format, and to the students who are learning in this equally bizarre format. But I'm glad I'm not doing that anymore.
But I think Colin and I can both agree, as people who have taken classes and had to learn how to now teach in this format, even in an informal learning sort of setting, it's hard on both sides.
And it's been tough, even though, we've all been working from home now for a year, and my company is pretty good about that. We had a strong work from home culture even before the pandemic hit. But I met a new coworker of mine. We all got our COVID shots on the same day, and there's this guy who joined the company in the last year, and he comes up and says, "Oh, hi, Charles." And I thought, "Oh, you're David. I have never actually met you. You're a lot taller in person than I thought you were." So I think it's going to be really interesting once we start going back to the office and try to remember who we all are, and we have to wear pants now and things like that.
I had a similar experience. I was at the park with a friend of mine a few weeks ago, and someone that I had worked with. I'm involved in the learning assistant program at CU. And one of the people that I had only ever met remotely, who, and I had seen his face and heard his voice, he came up to me at the park and was like, "Colin, is that you?" And I recognized him immediately, but I had no idea who he was. I was like, "Yes." And he's like, "It's okay. I'm Connor. We do LA stuff together." And I was like, "Oh my God, this is nuts." It was the weirdest experience. I think you're right. That's going to start happening a lot more.
Yeah. And honestly, it's kind of nice to work in, the company it's several thousand people, and I don't know them all, but I recognize almost everybody. But we all have name badges on. So you can always say, "Oh, hi, Mary." It's nice. It's weird to interact with people that don't have name tags on. "You look very familiar. What's your name?"
But I think one thing that I've noticed too is that a lot of people assume that because we're scientists or computer scientists or people who are used to, being very focused on our computers all day, every day, that this whole work from home and doing our own thing has been fine. But I've noticed for a lot of us, I've just been going back into the office for the last 2 weeks, and it's so wonderful to actually see a live person again, even if we're not actually working together, just to have someone walk past my desk and a human.
So we all got our COVID vaccines kind of the same day. It was one of these, "Oh, hey, we got 500 vaccines. Everybody come up." And you're supposed to hang out for 15 minutes afterwards. I think I was there for an hour and a half, just chatting. "Oh, I haven't seen you in a month." And that was really nice. No, I can't wait to go out. I can't wait to start going back into the building. And yeah, like you said, the building out in Westminster, we call it the Dish because it's got the big roof thing. It's a cool building. It's fun to be in.
I've always wondered if it ever hails or otherwise there are projectiles. I mean, the whole building is made of glass. Is it just super strong glass, or
it's
what's
very
the deal?
strong glass? Yeah.
Every time I see it, I'm
they
like,
did tell us when we first started there, they said, what do you do in the event of a tornado? And said, "We'll get away from the windows." We're like, "Where?"
It's one big window. It's the whole building.
Window, yeah, exactly.
It's got to have great lighting though, huh?
It's great lighting. Yeah, it's distracting actually looking out on the lawn and seeing people playing, disc golf out there.
Right.
I do miss working in Boulder, where I could go, on my lunch hour and just run up to Chautauqua and go for a hike or whatever. Now on my lunch hour, I go for, a run on the Big Dry Creek Trail, which is nice enough, but it's not the same. Commuting now, it's half an hour by car rather than half an hour by bus. So
We are pretty spoiled up here.
we're very spoiled. Yes.
Speaking of, with our last couple of minutes, we also wanted to plug your blog because the Outer Sanctum is super fun. It's a really cool thing to read. And it's got all sorts of interesting stuff about not just your work, but also all of this outdoorsy stuff you like to do: backpacking, rock climbing, caving, trail running, all of this other stuff. Is there anything you want to tell us about your blog and some of this other stuff that you're doing?
So yeah, I started making a blog, back in the 90s, back before the term blog even existed. But it's, I write down stuff, I take pictures, and it's mostly for my own benefit, where it's fun to go back and read, oh, hey, yeah, that time in 2000 and whatever that I did this. And it's funny what constitutes a blog worthy adventure has gone up. Like it used to be, oh, we hiked up to, the first Flatiron, and now it's a, whatever, first Flatiron. So it's funny, even, living in Boulder for 20 years, your threshold for adventure goes up. And you sort of get sucked into this athlete mentality and this sort of crazy person mentality. When I first flew out to Colorado, I was sitting on a plane next to this couple who was coming out to run the Pikes Peak Marathon. I said, why in the hell would anyone do that? 4 years later, here I am running up Pikes Peak going, why would anyone do this? So I don't know. Mostly the blog is there for just, interesting adventures and various world travel. I got a chance, actually, one of my most recent big adventures was in 2017. I was involved in the New Horizons mission, when New Horizons was flying past 2014 MU-69, the Kuiper Belt object now known as Arakoth. So I got sucked into this, and this is one of the fun things about academia, is that you just have, one of the professors came down the hall and said, "Hey, Charles, do you have a passport?" "Yes." Can you drive a manual transmission on the wrong side of the road?" "Yes." "Why?" "Well, you want to come along to South Africa and help run some telescopes for this occultation project?" "Sure. When?" "In a month." "Okay." So I got to go to Cape Town for a week and a half with a random assortment of other people, including a bunch of CU undergrads and grad students, and it was so fun. It was so much. Well, we didn't get a lot of sleep, but it was such an adventure. So that's pretty fun to write about, things like that.
Very cool. Well, hey, Dr. Charles Danforth, we've hit our hour limit for our episode. So I want to say thanks so much for joining us and giving us your time this morning to tell us about the story of your life, and remind people that you don't have to stick with the thing that you decided on when you were 18.
The story of my life so far.
So far, yeah, exactly. It's not complete.
I think that's the theme of the whole thing, is that, it's okay to change your mind, and even if you've sunk 20 years of your life into moving in one direction, you can try something different.
Absolutely. It's
been a pleasure.
All righty, and that wraps things up for today's episode of A View from Earth. We'd like to thank Dr. Charles Danforth again for giving us his time this morning to tell us the story of his life so far. Hey, tune in next week for a conversation with Dr. Robin Rumstad about whether or not magnetic fields are required or play a large role in the development of life. It's going to be really cool, and so tune in for that. Check out our website at www.colorado.edu/Fiske. Lots of fun stuff to do there. Among those fun things, you can submit questions to us about whatever you're curious about, and we'll pass it on to our experts and ask them in the Capcom Q&A portion of the episode. You can also make a monetary donation to the podcast if this is something you enjoy listening to. If it's an important part of your day, then you can be the reason that the podcast makes another episode, and for that we thank you. We are available on SoundCloud, YouTube, Spotify, and Apple Podcasts. Make sure to, regarding however you interact with the podcast, like, comment, subscribe, send us questions, send us your thoughts. We love nothing more than to talk with our listeners, to interact with you. So please, anything that you want to do it. Let's start a conversation. Thanks so much for listening. We'll see you next week.